Let's see how can we solve this question. Lead code number 54201 matrix. Let's see what's the question. We'll be given an Ampersand binary matrix, which means it contains only zeros and ones. We need to return the distance of nearest zero for each cell. Okay, the distance between two cells sharing a common edge is 1. Okay, so for every cell we need to return is nearest zero. Okay, for 0 this is the nearest one, so distance will be 0. So for every 0 it will be 0. Let's take example to understand. For every 0 the distance will be 0. We need to calculate for ones. Okay, let's see for this one. You can see this one has nearest zeros too. So one more thing is we can only check in 4 directions, not diagonal. So for this one we have these 3 zeros, minimum distance is 1. For this one we have this 0, distance is 1. For this one this 0 1. If you see for this one it has no adjacent zeros, here it is 1 and here it is 1. So for this one the nearest 0 is, if you go this side 2 steps, if you go this side 1 2 2 steps, if you go above this 2 steps, above this side 2 steps, you got so the minimum distance is 2. So we need to return the distance of 0 for every cell. Okay, it will be, this is the answer. So let's see how can we solve this. Okay, so what I'll do is I'll take a result array where I'll store the my answer. What I'll do is, I know for every 0 the answer is 0. For every 1 I don't know this answer. I'll insert this I'll insert with minus 1. What I will do is instead of checking the nearest 0 for each one, I'll check for each 0 what are its nearest one, nearest ones. I mean, within how many steps I can reach to a particular one from every 0. Okay, for that what I will do is I'll store all these zeros position in a queue. Let's suppose 0 comma 0 0 1 0 2 and 1 0 1 2. Okay, so I'll check 4 directions for each of these cells. For 0 0, if I check in 4 directions, there is no 1, so I can remove it. So right now I'm at I'm checking at level 1. Okay, 0 0 I'm not able to. I'll check for 0 1 0 1. If I check top, there's nothing. 0 0, if I check down, there is 1. So I'm able to reach to that 1 in within 1 steps as well. Okay, within 1 step. So I'll change this position to 1. Okay, and I'll add it in my queue. Okay. I'll tell you why I'm keeping a space here, which is 1. So these are the cells I will iterate at when steps are 0. These are the cells I will iterate when steps are 1. So other cells that I am able to reach through these cells will have answer as 2. So that's why I'm keeping a distance here. So 0 1 I have checked and I remove it. 0 2, so I can't go to anywhere. I have for 1 0 1 0 you can pop as 0. If you see right side it is 1, but it is not minus 1. That means it is already visited, and we have filled the distance for it. Only if it is minus 1 we have not visited it. We haven't calculated the distance for that set. Okay. from 0, if you check in the bottom, it is 1 and it is -1. Okay, I'm able to reach this one step. And I'll remove this one from here, and I'll add it the this position, which is 2 comma 0. And I'll check for 1 2. Top 0, there is no right. Left is 1, but it is not -1. Bottom is 1, and here it is -1, so it is not this step. What I'll do is I'll remove this. I'll mark it as 1. I'm able to reach this in one step. Then add that cell position in view, which is 2 comma 2. So now I'll increase the steps, which is 2. So whatever cell I will reach right now, it takes 2 steps. I mean, the nearest 0 for that will be 2. So we'll check for 1 comma 1. So if you check for 1 comma 1, top down, top 0, this side 0, this side 0, bottom. It is minus, it is 1, and here it is -1. I'm able to reach it. So what I'll do is I'll remove this, fill this with steps, which is 2. I'll add this here, that's it. Okay, which is 2 comma 1. Check for 2 0. 2 0, this is everything is done for this. So similarly for 2 calls, everything is done. The steps will be 3 right now. Whatever cell I'll reach right now, then just 0 for that cell will be 3 steps. That's for 2 1. Here it is 1, here it is 1, here it is 1, but all of them are full. So I don't need to check. So this is my answer. Here you can see. So let's see how can you write code for this. You see, we are going level by level. Now incrementing the steps value +1 at every level. If you are going level, you know which algorithm we should implement. Yes, it is BFS. When I am crossing, comment this. And this in columns. So I need a result of it. Result into involves and columns. Okay, and I need to initialize this. So initially everything will be 0. So if it is 0, I need to do it. I don't need to do anything. If it is 1, so what I will do is I'll take a Q. I need to fill this with row and column. For that I will take a new class. So I can store row and column easily. Okay. And this is done. I need to install my queue. New declaration stuff. So if it is equal to 1, I need to insert this with -1. Okay, this in my pair of IJ. So remember, I haven't written J before. I use from 0 to n, J is from 0 to n. Okay. So my initialize is done. Now I need to solve it. Okay. So what I'll do is I have a separate function for BFS. At the end, I return the result. So in separate function, what I'll have is I'll have my queue, I'll have my result, I'll have my managers, I'll have my queue, that is one. name my M and N. So I guess this will be enough. So let's write BFS. BFS. Matrix and P. Then, so what I need to do is I need to have a prompt value. Steps, I'll give the steps so it will be easy to understand. Steps as one. Okay. So state while show is empty. Not empty, I will go inside it. So I need to have my D row and D column so that I can go in 4 directions. And this one, same row, next row, center, D column, same column, next column, same column, before column. Okay. So what I'll do is I need to have my queue length so that I can pop uh, pop those elements from queue which are at a particular level. Okay. So while this queue will be as well as that is inside, I'll pop the top one, pop current, to the pull out. I'll pop the top one. Next, I'll have my current one column. Current row, current column. So my bad, I have, if it is 0, I need to add this in queue. Sorry, I have written wrong earlier. It is 0, I need to add. If it is 1, I need to keep it as -1. This works. So I'll check. I need to check the 4. I need to check 4 directions. So my new row will be current row plus 0 of my new column will be current column plus the column of 0. If my it should be a valid set, it should be greater than or equal to 0, and it should be less than. It should be greater than column should be greater than or equal to, and it should be less than. And matrix of ij should be 1. So that I can fill it in result, and at the same time in result it should be -1. It is not, it shouldn't be listed earlier. That's the case. I will change my result of ij to steps. Okay, and I'll add this new row and column to my queue. And pair of everything is done. I'll implement queue length. So it should be steps. So so it should be I. Now this ij should be new row new column. New row new column, and similarly here also. New row. Here also. What's the row? It should be w equal to -1. Let's try to submit this. So it got accepted. Now let's analyze time and space complexity. So let's see time. So I have an M cross N here, and I have a BFS. So M cross N. In BFS it would be for every cell I'm checking in 4 directions. Space, it would be big of N for result, and Q may contain at max loss of bits because I'm into. So yeah, that's the time and space complexity. Um, Thank you.